Alright, so we've been told to decompose this into partial fractions. Alright, so the first thing that we're going to do is we're going to compare the power of the denominator, alright, against the power of the numerator. Alright, so in here we can see that our denominator has power, which is its highest power, which is x squared, is less than our numerator's highest power, which is x cubed. So this is an improper fraction. All right, this is an improper fraction. So what we have to do is first we have to divide, all right, with long division of polynomials. Okay, so that's the first thing we do. We divide. So we're going to put here, we're going to say x cubed plus 3x plus 2. Right, we're dividing it by x cubed minus 2x. So in here, we're going to first put x cubed. We do not have a coefficient for x squared, right? I mean, we do not even have an x squared here. So we're going to put plus 0x squared, okay? Plus 0x squared plus, minus 2x minus 2x, and we'll put a plus 0 in case we have a remainder with a constant. So we just put a plus 0 just in case. So whenever we're doing long division, the three steps I have to follow is we divide, then we multiply, then we subtract. All right. So the first step, we're going to divide. What do we divide? Our leading terms. Okay. We're going to all our leading terms by x squared. All right. So we'll start with our first leading term here. It's x cubed. So we'll say x cubed divided by x squared. We are going to get x. All right. So we're going to put here x. So we've done step 1, we divided. Then we multiply. So x times x squared, we get x cubed. Okay. X times 3x, we get 3x squared. All right. X times 2, we get 2x. All right. So we got now step 3, we subtract. All right. So put it here. X cubed minus x cubed, we get 0, so it's gone away. 0x squared minus 3x squared, we get negative 3x squared. All right. Negative 2x minus positive 2x. All right. We get negative 4x. All right. We get negative 4x. And then we just drop down our 0 here. All right. We drop down this 0 here. Right? Then we repeat our process again. We divide. So what are we going to divide? Our leading term, right? So we say negative 3x squared divided by x squared. We're going to get negative 3. All right, so we put here minus 3. All right, so negative 3. Now we've divided. So now the next step is to multiply. So say negative 3 times x squared, we get negative 3x squared. Negative 3 times 3x, we get negative 9x. Right? Then negative 3 times 2, we get negative 6. All right, so we have multiplied, then now we subtract. Negative 3 minus negative 3, we get 0. Negative 4 minus negative 9, that's the same as negative 4 plus 9x. All right, because negative and negative make positive. Remember that in integers. So negative 4 plus 9x, we get positive 5x. Okay, then 0 minus negative 6. All right, so this negative and negative, it makes it positive. So we're going to get positive 6. So the first thing we're going to do to our fraction here, right, we're going to say, just make space here. All right, so we're going to say x cubed minus 2x, all right. Now, we also have to factorize our denominator. We have to put it into simple terms because we're going to be decomposing this fraction and we're going to look at the possibilities we can have. All right, so we're also going to have to factorize this quadratic expression below. All right, so what we're also going to do is this. We have x squared plus 3x plus 2. All right, we have to factorize it. So remember, we have to write down our a, b, and c. So our a, which is the coefficient of x squared, is 1. Our b, which is the coefficient of x, is 3. And our c, all right, equals 2. All right. So what you're going to do, you're going to say a times c, right? A times c, that's 1 times 2. All right, that's 1 times 2, we get 2. Okay, we get 2. So now we have to look for two numbers that when we add these two numbers, we are going to get 3. And when we multiply these two numbers, we're supposed to get 2. All right, so let's look at factors of 2. We've got 1 and 2. All right, if you multiply 1 and 2, you're going to get 2. If you add 1 and 2, you're going to get 3. So this quadratic expression can be broken down to x plus 1, okay, x plus 1 inside x plus 2, x plus 1 and x plus 2. Okay, so let me just go to a new sheet so that we can start the decomposition of this partial fraction. We can decompose it into partial fractions. All right, so we'll just go to the next page. All right, so what we're going to say is what we're going to say is x cubed, all right, minus 2x, all right, We write down our new factors which we found, x plus 1 and x plus 2. All right, so we're going to write our identity symbol. All right, so now basically we're going to break down this fraction into parts. All right, so we're going to first find out what our remainder was when we divided. Okay, it was 5x plus 6. For what? Let me just I'm waiting for the board to load. Why is it taking long? Oh, finally. Oh, the board is taking long to load. Okay. Ish. Let me just work on one page so that it doesn't do that again. All right. I'll just have to work on one page. Yes, we had x cubed minus what? X cubed minus minus 2x over x squared over x squared x squared broke it down to factors of x plus 1 and x plus 2. Those are the factors, right? I hope you can remember some of the terms I put down there. X plus 1 and x plus 2, if I'm not mistaken. This is what we broke down that quadratic equation into. All right, so we're going to put now our identity symbol here. All right, I'm going to first put x minus 3 plus our remainder, which was 5x plus 6 over x plus 1 over x plus 2. But this is not the answer here. All right, we're now going to break this. All right, we're now going to dissolve this one into partial fractions again. So what's now going to happen is we're going to look for two factors, which when they're multiplied, they'll give us this expression. And then when they're added with this expression, they'll give us our original expression. All right, so we're going to now break down this 5x plus 6 over x plus 1 over x plus 2. We're going to decompose it now. So what's going to happen is we're going to write x minus 3 plus, all right, okay, we're going to first put our first factor here, which is x plus 1, all right. So our numerator has to be at a less degree than our denominator. So our denominator is x to the power 1. So our numerator will be a constant, which is a, right, over x plus 2. All right. Again, our numerator has to be 1 degree less than our denominator. So our numerator will be constant. I also want you to take note of one thing. There might be some points where you'll find a numerator which is x plus, let's say for example, x plus 3 squared, all right? Just because it's you've got the squared here and expand it, you're always going to look for, you always want your numerator to be at a less degree than your denominator. So you're not going to worry about these two here. You're going to still have a constant as your numerator, all right? So in cases where you see you have a denominator which is to the power 2, to the power 3, or to the power 4, you're still going to, your numerator is still going to be less by 1 degree, all right? And you're still going to take this as x to the power 1, all right? I just hope you take note of that. All right, so we have decomposed, all right? Now we have to find the values of a and b, all right? So what is going to happen is to get the values of a and b, we're going to multiply throughout, all right? This whole expression, this x minus 3 minus 2x over x plus 1 x plus 2. So we're going to multiply throughout with the common denominator, all right? With the common denominator. So you're just going to put brackets here, all right? Our common denominator is x plus 1 times x plus 2. So I'm going to put it here. I'm going to multiply throughout with our common denominator, right? So we'll start with our term here, all right? If we multiply this expression with this term I've circled in 0, we're going to cancel out x plus 1 times x plus 2, all right? So we're going to remain with x cubed minus 2x on our left-hand side, right? If we multiply x minus 3 times this expression here, right, we're going to get x minus 3, right, open brackets, x plus 1, close open brackets again, x plus 2, right? All right, if we multiply a over x plus 1 times this expression here, we're going to remain with a times x plus 2, all right? Because this will cancel, all right? And then we also cancel this x plus 1 here. We're going to remain with a times x plus 2. Right? Similar here, multiply b over x plus 2 times this expression, right? This will be cancelled out, excuse me, and we're going to remain with b open brackets x plus 1. All right, so what we can do here is we can look at values, all right? We can start putting values here to start getting rid of these other terms so we can find the value of a and b. So what I'm saying is, for example, you can say when x equals -1, all right? When x equals -1, all right? On our left-hand side first, we'll start to operate on the left-hand side, right? We'll have -1 cubed minus 2 times -1, all right? And then if we come to our right-hand side, all right, this -1 plus 1, you're going to get a 0, all right? And 0 times this whole expression is going to be cancelled out, all right? This whole expression is going to be cancelled out, all right? Maybe let me cancel it out for now. Gets cancelled out when x equals -1. Why? Because we have a 0 here, and 0 times anything is 0, okay? Here we're going to say -1 plus 2, we're going to get 1, all right? So 1 times a, we're going to get a, all right? Then b, all right, -1 plus 1, we're going to get 0, right? We are going to get 0, right? And then 0 times b, 0 get cancelled out, okay? So -1 to the power 3, if I change the board, I hope it doesn't take long to load. I hope it won't take long to load. All right. Okay, so we had -1, okay, -1 to the power 3 minus 2 times -1 equals a, all right, equals a. So -1 cubed is -1. -2 times -1, that's +2. We're going to have 1 plus 2, right? 1 plus 2. -1 plus 2, yes. And we have a here, right? Right, -1 plus 2, that is +1. So a equals +1, right? A equals +1, all right? Then, all right, let me rewrite the expression we had earlier on. We had x cubed minus 2x equals, we had x plus 1 and we had x minus 3 x plus 1, okay, and x plus 2, x plus 2 plus, okay, we had a open brackets x plus 2, a open brackets x plus 2 plus b open brackets x plus 1, all right, b open brackets, all right. So if we say when x equals -2, all right, when x equals -2, all right, you notice if we put the -2 here, all right, -2 plus 2, that is 0. So this expression will be cancelled out, all right. Even our a expression is going to be cancelled out, all right. So we're going to remain with b open brackets -2 plus 1. So now this side we're going to first have -2x cubed, -2 cubed minus 2 times -2, right, equals b open brackets -2 plus 1, -2 plus 1, all right. That is that's -1, so b equals -1. Okay, b equals -1. -2 cubed to give us -8. -2 times -2, we get +4. All right, we get +4. -8 plus +4, we get -4. Okay, -8 plus we get -4. Then we're going to divide both sides by -1 to get our value of b. So we're going to say 1, 1, right. So we're going to say b equals +4. B equals +4. All right. A equals 1, B equals +4. So we go back to our expression earlier on. All right. So this x minus 3, we're going to substitute our a here with a was what we found. A was negative 1 and b was positive 4. So we're going to rewrite our expression. Okay, we rewrite our expression now. Right, so we're going to say x cubed minus 2x over x plus 1, x plus 2, and then we're going to write our identity symbol of x minus 3 plus, right, plus 1. Our a value was 1, if I remember. 1 over x plus 1 plus 4. Our b was 4. 4 over x plus 2. And that is your answer.